This is Probability Lesson 2 of 4. Today we cover mutually exclusive events, the addition law, and complementary events. Quick recap from Lesson 1. We use diagrams to list all possible outcomes and calculate probability as favorable outcomes divided by total outcomes. 2 quick questions. Answer instinctively. Question 1. A student is late for school. What is the probability he gets booked for late coming and is punished? Most people would say probably high. Question 2. A student is late for school. What is the probability he is late and arrives on time? That should be 0. It's impossible. That second question is the key to today's lesson. Some events cannot happen together. Today, we give that a proper mathematical name and a powerful rule. Section A. Mutually exclusive events. 2 events are mutually exclusive if they cannot occur at the same time. Real-life examples before the maths. You cannot be at 2 places at the same time. A single integer cannot be both odd and even. A tossed coin cannot land on both head and tail. In probability, if events A and B are mutually exclusive, P of A and B equals 0. Visually, mutually exclusive events have no overlap in a Venn diagram. Events that are not mutually exclusive do overlap. The intersection contains outcomes where both events happen together. Let's work through an example. Choose a digit from 1 to 9. Event A, choosing a prime number. Event B, choosing an even number. Here are the digits 1 to 9. Let's place each digit into the correct region of our Venn diagram. Let's go through each digit. 1 is neither prime nor even. It goes outside both circles. 2 is both prime and even, right in the intersection. 3 is prime, not even, inside A only. 4 is even, not prime, inside B only. 5, prime only. 6, even only. 7, prime only. 8, even only. 9 is neither. It goes outside. Since A intersection B equals the set containing 2, which is not empty, A and B are not mutually exclusive. The number 2 is both prime and even. Now consider, event A is choosing an odd number. Event B is choosing an even number. Now consider intersection B is the empty set. No number is both odd and even. These events are mutually exclusive. Let's pause here. If anything about mutually exclusive events is unclear, click the microphone below and ask. Take your time. Section B. The addition law of probability. For mutually exclusive events A and B, the probability of A or B equals P of A plus P of B. Just add them. Let's apply this with our odd and even example. P of odd is 5 over 9. P of even is 4 over 9. P of odd or even is 5 over 9 plus 4 over 9, which equals 9 over 9, which is 1. This makes sense. Every digit from 1 to 9 is either odd or even. So the probability of getting one or the other is certainty. Very important. This addition rule only works when A and B are mutually exclusive. If they are not mutually exclusive, adding P of A plus P of B would double count the intersection. We address that in a later lesson. Section C. Complementary events. The most powerful shortcut in probability. Consider picking a random letter from the 26 letters of the English alphabet. Event A. Picking a vowel. A, E, I, O, U. That's 5 letters. P of vowel is 5 over 26. Now, what is the probability of not picking a vowel? We could count all 21 consonants. Or we use this shortcut. P of not A equals 1 minus P of A, which is 1 minus 5 over 26, equals 21 over 26. This works because every outcome is either a vowel or not a vowel. There is no third option. Here is the general rule. P of A plus P of A complement equals 1. So P of A complement equals 1 minus P of A. Complementary events are mutually exclusive, and together they cover the entire sample space. Quick check. If P of A is 0.3, what is P of not A? 0.7. Always 1 minus P of A. Here's a deeper question. Can two events be mutually exclusive but not complementary? Think about it. Yes! Odd numbers and even numbers from 1 to 9 are mutually exclusive, and they happen to be complementary because they cover the entire sample space. But if our sample space also included decimals like 1.5, then odd and even would still be mutually exclusive, but would not cover the entire sample space, so they would not be complementary. It depends entirely on what the sample space is. Let's pause again. If you have any questions about the addition law or complementary events, click the microphone below and ask. Don't be shy. Let's summarize Lesson 2. Mutually exclusive events cannot happen together. P of A intersection B is 0. The addition law says P of A or B equals P of A plus P of B, but only for mutually exclusive events. Complementary events cover the entire sample space and their probabilities sum to 1. The shortcut, P of not A equals 1 minus P of A. Here's your cliffhanger. What if you flip a coin twice and want the probability of getting 2 heads? Neither addition law nor Venn diagrams help here. In Lesson 3, we learn the multiplication law, the most efficient tool in this chapter. And it connects directly to the food for thought question about 6 coins from Lesson 1.